Hey Rockstar Chem students, we're back and this is truly the final video, alright? This one is orbital diagrams. Trying to use a highlighter and use that. So this is orbital diagrams. This is the last part of page 16, and now that we have shorthand electron configuration, orbital diagrams should go very, very smoothly. So orbital diagrams just give us very specific electron addresses. So we're going to go ahead and stick with the addresses part. All right. So this gives us electron configurations, give us like an overview, and then orbital diagrams give us very specific information about it. We can eventually get to the quantum numbers, but that's not really anything for this class. So let's just move on and jump into some vocab. All right. So our vocab, core electrons, these are the ones that are inner electrons. All right. They are not involved in bonding. They do have an important piece, but for right now, that's not our concern. All right. So they're not involved in bonding. Now, if we look at our valence electrons, these are the ones we are most concerned with because these are our outer energy electrons. And they are involved in bonding. So it's very important to know how many valence electrons we have because that'll determine how they bond, who they bond with, etc. Okay, one more piece of information there. We have Hund's rule. Hund's rule says basically that electrons with the same spin can't be in the same orbital. All right. So what we're trying to say is we've now talked about like our electron configuration give us energy levels and sublevels. With our orbital diagrams, we're taking it down one more level and we're going to talk about orbitals. And this is where 2 electrons can fit. So only 2 electrons can hang out in here and they must have opposite spins. Okay, so we're getting a little bit out there, but it'll be okay. All right, so if we look at it, remember our S sublevel could hold 2 electrons, right? Our P sublevel, or so 2 electrons, so that means it has 1 orbital because each orbital can hold 2 electrons. So P, remember, could hold 6 electrons, so it has 3 orbitals. D had 10 electrons, or could hold 10 electrons, and F 14, right? And each dash can hold 2. So all we're going to do is use our shorthand electron configurations to do our orbital diagrams. So we've got sulfur. We just did its electron configuration up there, right? Ne, 3s2, 3p4. So we're going to try that again or rewrite that. We've got Ne, 3s2, 3p4. So what we do to do this is we add dashes for what orbital. So we've got 3s. And we said S had 1 dash, so we're going to put 1 dash. And there are 2 electrons in there, so we put 1 with an up spin and 1 with a down spin. All right. Then we have 3p. Remember, each p, we can have 3 dashes, so we're going to have 3 dashes. Then what we do is we fill them singly. So fill it singly. 1, 2, 3, all with the same spin, and then go back and double them up. This is like if you have the opportunity to have your own room in your house, you're going to take it, you're not going to share with your little brother or sister, right? And that's the orbital diagram for sulfur. So let's try xenon. All right, we go back up to xenon. We've got Kr. This is our shorthand, right? We've got Kr. Then we have 5s2, 4d10, and then 5p6. Okay, just as a quick aside here, the Ds, the 4Ds are not valence electrons, but I do like to see them in the orbital diagrams. So we've got 5s, right? We've got our 2 electrons in there with opposite spins. Then we have D, which has 5 dashes. So we're going to go a little bit higher energy and we're going to put 5 dashes there. And this is 4D. And now remember, we fill them all singly before we go back and double them up. So fill singly and then go back and double them up. There's our 10. Whew. One last one to draw. We have 5p, so 5p, 3 dashes because p has 3 dashes. And remember, fill them singly, then go back and double them up. And you see why xenon is unreactive. Look at that. All those are full, so it can't take on any more electrons, and it doesn't want to give up any electrons. We look at sulfur. We've got some maybe empty spots here, right? Right? We could have some electrons go there. Okay. Now let's look at iron. So we go back up, get iron's electron configuration. We've got, oh my, I'm still trying to write in a highlighter. You guys didn't remind me of that? Thanks. Okay, so we've got argon, and then we have 4s2, 3d6. Okay, my writing got a little rough there, but hopefully we can handle it. Okay, so we've got 4s, lower energy, one up, one down. Okay, because remember they have to have opposite spins. Then we go D, 3d. And each D, or there should be 5 dashes for my Ds. Okay, and then remember, fill it singly, then go back and double it up. So all of them with up spins. And go back and double it up. Boom, there we go. So iron could get maybe some more electrons, or maybe it could give some electrons away. Okay? Awesome, thanks. That's our video. And we're done with Unit 2.